Welcome to Kishore's Neet Padasala. In this video lecture, we will see certain applications of Newton's laws of motion. These are all the most common type of questions. Okay, suppose from the wall there is a block of mass m hanging. Okay, then first you find the forces acting. Okay, since it is the string, massless string, the force acting is T. Okay, see that whenever there is a block, tension always acts in the opposite direction of the block. Okay, so only I am putting here in the arrow in the upward direction. First case, when the system is stationary. System is stationary in the first place. So this is the block M. Upward force is tension, downward force is mg. I have said in the previous video that net force is equal to ma. Here T minus mg, since it is first we are assuming it as a stationary, acceleration due to gravity is 0, so T is equal to mg. Okay, now let us assume the second case. The system is moving upwards. Okay, the same mass m, and there is a string connected, so the upward force acting is tension, downward force is gravitational force, that is mg. And in this case, let us assume that the system is moving upwards with acceleration e. Then net force is equal to ma. Net force means ma. Net force means it is the positive force. Since here also positive sign is there, this also must be positive sign. When the object will move up, when there is a positive force is in the upward direction, so more force will, if it is in the upward direction, then only the system will move upward. So T is more than mg, so T minus mg is equal to ma. So this is the equation when the system is moving upward. Now let us assume that system is moving downward. Okay, the same block of mass m and the same tension is acting the against direction of the block, the groundward gravitational force is mg, the block is moving in downwards with acceleration a. Net force is ma. Okay, net force must be positive. When it will be positive? When it is greater force minus smaller force. Why the system? Now we are assuming the system to be moving downwards, so downward force must be greater, so mg minus T is equal to ma. T is equal to mg minus ma. Okay, this is the equation when the system is moving downwards. Now let us work out this thing. See that from the wall a rope of mass m. Previously we assumed a massless rope, but here we are assuming the mass of the rope is m and this distance is x. And let us find the tension of the rope at x. Okay, for L length, okay, L length is the mass, for L length the mass is m. Then for the x length, what is the mass? The mass is mx by L. So for mass of the x is m into x by L. Okay, now let us find the tension. Tension on the x is, okay, m into g. Mass of x into g. Mass of x we found out to be m into x by L into g. Suppose if the system is moving upwards, okay, then this is the rope, tension is in the upward direction, gravitational force, that is mxg by L, is in the downward direction, and system is moving in the upward direction with acceleration mx. System is moving upward with acceleration e. Then upward force, since it is moving upward, so upward force minus downward force. Downward force is the gravitational force, is equal to mass into a. Mass of the x portion of the rope is mx by L. Okay, suppose let us assume that the rope is moving downward, moving down. Okay, then the same thing, but here first we want to, since it is moving down, downward force minus upward force is equal to m into a. Downward force is m x g by l. This is the weight of the rope, minus upward force is tension. Tension is the upward force, that is equal to mass of the rope is m x by l. That only we have found out here, into a. So tension is equal to m x g by l minus m x a by l. This is the equation when the system is moving downward. Okay, now let us see this thing. The rope of mass ms is there and there is a block of mass m. The whole length is l. So for ms mass, the length is l. So for x length, what is the mass? So mass is x into ms by l is the mass of this portion. Then what is the tension at this tx? If the system is at stationary, then it is at this rope. Okay, the downward gravitational force is x into ms l g, and there is one block of mass m. For this block the gravitational force is mg and tension is upward. So tension is equal to x ms by l into g plus mg. Upward force is equal to downward force. Suppose if the system is moving upwards, okay, then at the rope tension is upwards, the gravitational force of the rope, that is x ms by l into g, is downward. Then on the block of mass m, the gravitational force is downward, but the system is moving in the upward acceleration with a. So tension, upward force minus the sum of downward force, that is the sum of gravitational forces of rope and the box, is equal to ma. So this is the upwards acceleration motion. Suppose if it is moving downwards, then downward force minus upward force is equal to ma. Downward force is the gravitational forces of the string plus gravitational motion or gravitational force due to the block minus upward force is tension, that is equal to ma. Okay, this is the equation for downward motion. So upward motion, upward minus downward force, downward motion, downward minus upward force is equal to ma. I hope you like this lecture. If you like this lecture, please subscribe Kishore's Neet Padasala. Thank you.